introduce our plenary speaker for the morning. Amir Roth is a technology manager at DOE's Building Technologies Office. There he oversees research, development, deployment, and standardization portfolios in the areas of BEM. Also building controls and national scale pathway planning and impact analysis. He has a lot of projects in his portfolio. I'm going to list them off. They include the Energy Plus Whole Building Energy Modeling Engine, the Radiance Lighting Engine, the Open Studio Software Development Kit, the Scout Technology Adoption and Diffusion Model, and providing technical support for ASHRAE Standards 140 and 229P. He's a member of ASHRAE and ABIPSA, and very puzzlingly, he added to the end of the intro, "Go Birds," which I can only assume means he's a fan of birds. So, without further ado, I'd like to welcome Amir Roth up to give his. Oh, well, so you don't like birds?
No, I do. Not those birds.
Well, I'll let you defend yourself. Why are you being so frustrated? Yeah, I'll leave it there.
Yeah. All right. Is this full screen or should I?
I tried.
Full screen it? Control L, is that right? No? No, that's okay. We'll do it this way. All right, well, thanks everyone. Yeah, going to talk about something a little bit different today. No specific mentions of Energy Plus or anything like that, just kind of a little more high level, a little more about, observations, going both forwards and backwards, about what's going on in this industry, what's going on at ASHRAE. I've developed a few of these over my involvement with a number of ASHRAE standards that Elise just mentioned. So ASHRAE standard 229, and I'm mostly going to be talking about interoperability standards. So 140 is not one of them, like ASHRAE 229, of which I'm a member. 205, which you may be familiar with, not a member, but another standard that is BEM relevant. And then I'm a fan of Neil Cruz, and so I'm never going to have as many hats as he does, but I am starting to I've been wearing a building automation hat for the last 6 years as well, so I'm involved in a number of those standards as well, and you kind of start to see the same things happening over and over. And Elise actually gave me a very good segue here by putting up a John von Neumann quote, the father of really the father of computer science as we know it today, invented the solid state transistor, invented the stored program concept for a computer, invented, sequential programming. Where would we be without, Johnny VB or VN these days? But yeah, that's the industry that I came from. I'm not a modeler by trade. And it's actually fairly striking to compare the computer industry in general to what's going on in BEM and building automation. The computer industry is one of the most highly standardized places you will see. Pretty much everything is standardized. Hardware interfaces and ABIs are all standardized. x86 instruction set and all of its clones, USB, memory ports, bus configurations, everything like that. Programming languages are all standards. All the communication protocols up and down the stack, from Ethernet, Bluetooth, TCP/IP, the most widely used communication standard in the world, all the security standards, communication standards at the application level, like SMAP and HTTP. Data is all standardized, for every application space that you want. And this level of standardization is actually both a product of and a reason for that the computer industry is as big as it is. It would not have been able to get this big without the standardization, and that's because standards provide stable connection points both for new entrants to the industry, but more importantly for other industries to connect from the outside. Now, of course, digital standardization, has also created a good number of challenges for everyone. Cybersecurity is, of course, a challenge. Privacy, IP. Business models have been turned upside down, and some have become kind of more or less viable in the digital world. But somehow the computer industry has kind of managed to persist and grow despite and address all of these challenges, and I think there's some things we can perhaps learn from them. So by comparison, the BEM industry is not really standardized at all in the digital sense. And it probably should be because, I mean, there are, if you sort of take a step back and think about it, there are some clear benefits to doing so. And while there are challenges, you know, the challenges can be overcome, and we have templates for how to do so. Like, we will not be the first people to overcome these, you know, these issues, and, you know, solutions exist, and we can borrow them. So, just a quick picture of how digital standards help industries grow. So just think in the abstract of two industries, you know, A and B. I don't think you have to take pictures. Like, these will probably be made available or online, or you can always just ask me for them later. You can go ahead if you want, but I'm just saying you can have a much higher resolution image later. You know, you have a bunch of players, and if the two industries, A and B, are not defined, are not kind of mediated by a digital standard, then what you get is that sort of connections between players in these industries have to be point-to-point. So if you're one of the players in industry B, you basically have to create bespoke one-off connections to industry A, to the different players in industry A. You may have to actually develop relationships, you know, with those industry actors. And this, you know, this is a barrier to new people coming in, and to, you know, to existing, you know, to players in the industry actually, you know, growing their business and growing their market. So, you know, the picture on the right basically says, well, if you just kind of put a digital standard between these guys, you know, each one of them basically has to do, you know, X amount less work to try to kind of make these connections. But even more importantly, like any player in industry A doesn't actually have to know or have any existing relationship with anybody in industry B to do this. You just have to kind of play to the standard. Okay, let's talk about where this, you know, where the BEM world is in here. So let's start with you know, a canonical example, which is the BIM to BEM connection. How would folks at this point characterize, you know, the state of BIM to BEM interoperability? It's not great. I mean, industry-wide, point-to-point, there are, you know, good solutions and stable solutions, but industry-wide, like this is one of the first problems I heard of when I came to this industry 14 years ago. I don't think things have gotten significantly better. And there are a number of reasons for this, but you can argue that one of the reasons is that the BIM world doesn't actually have like a stable standard to, you know, to target, right? There's GBXML, but but it's not really a standard, and it's, you know, its evolution is such that it came, you know, it was very tool specific initially, and so, you know, it's not maybe general enough to address, you know, to kind of address like the BEM world at large. And so there just isn't really something that's cost effective, you know, for BIM players to target. And so, again, we're left with a place where, you know, the BEM folks have to do most of the work, and then the ones that sort of put it in have to do it, you know, potentially for, you know, for multiple vendors. But, you know, new players coming in, you know, have to do all this work, you know, to try to connect. So that's a historical one. And then let's look at one which is kind of a little bit more recent and top of mind, and that's kind of the code review example. So if you have a bunch of you know, players in the BEM space, and you have code jurisdictions and people that need to review models, if every vendor essentially has its output and its reports, either digital or human readable, you know, in their own kind of bespoke format, that really increases the, you know, the cognitive burden on the consumers of those, because then they have to, you know, learn to work with, you know, both, you know, their tools have to work with multiple tools, perhaps, if they have any tools, or, you know, their human reviewers have to, you know, learn to interpret, you know, results from multiple tools, et cetera, et cetera. And this, you know, creates a drag on this entire, you know, on this entire connection, essentially. Like the reason that things have not gone, you know, that more buildings don't use performance paths, this is one of the reasons. It's just, there's a lot of friction in code review, and that friction, a lot of that friction is born because there's a lack of standardization. So a few things here. So we're trying to, this boundary between energy modeling and code review, we're trying to address using a few standards that I just listed before. One of them is not a standard really, it's, although it may be a standard at some point, and that's the Building Data Exchange, which is trying to create a digital spec for the sort of the basic common outputs of energy models. This is a effort that's being led by BIPSA USA. So basically you could have all BEM vendors, in addition to doing whatever exports they want for their users, or whatever reports they have for their users, there would also be kind of a core standard report, that any number of actors could leverage, and this could be either code jurisdictions or, you can even think beyond that to GBCI and LEED and AIA 2030 and so on and so forth. So this is one. And then the other one is 229P. I don't know if that has been discussed in any of the working groups here today. But so 229P is, for those of you who are not familiar, it's intended to kind of be the, like a colloquial or informal description of it is it's trying to kind of be the 140 of rule sets and compliance shells. Like we're trying to, formalize and kind of inject a similar level of rigor and comparativeness to compliance calculations, or at least the compliance setups, not to the calculations that the engines underneath are doing. That's where 140 comes in. But we're trying to do that, for the rule set engines. Okay, so I think, that's just kind of an example of what I'm talking about. Let's see, how much time do I have? I don't know what I'm not like a self-timed speaker. I can go on for hours. So I think, some things that are important for this industry to think about are, in terms of like where we want to standardize. It's not that everything in the industry needs to be standardized, mind you. Like there does need to be, freedom to, to innovate. But the important places in which standards can really help are at the boundaries between industries, or at the boundaries, between, if the industry is kind of horizontally layered, which actually BEM is not. So, that's a little bit less of a concern. BEM is extremely vertical industry. You should try to think about like what are industries that are important for energy modeling to connect to. So I mentioned ASHRAE standard 205. If you're not familiar with it, it's a data standard for describing in detail the performance of HVAC equipment. So rather than a curve, you get like a multi-dimensional map that you can specify, and therefore you have a lot more sort of fidelity, and representation of the, of the way that the equipment actually operates. So you can think of ASHRAE standard 205 as kind of a boundary standard between energy modeling and HVAC manufacturers. I mentioned before, I work with a lot with building automation standards. The two standards that I work with there are ASHRAE 223P and 231P, both of which are going to lose their Ps at some point shortly. And 231P really is intended to be, this standard is called control description language, and it's intended to be a digital standard that connects energy modeling to the control implementation industry. So you can essentially, you have a digital control spec that you can both simulate in a BEM engine, and then take that digital spec directly, and then plop it into your Tritium, and it will actually run your equipment. So right now, that handoff is essentially a PDF that, a designer says, okay, I want, this is the operational scheme that I envision for, for my system, hands that off to a control engineer, and they sort of do their best to implement it or not, or they just implement whatever it is they know. And so, these are sort of two other industries that we've identified that we would like to have kind of better and more productive connections with. And this is why we're sort of trying to standardize the interfaces between BEM and those industries. And it's good to think about who else we may want to connect with. Okay, so the title of the talk is actually the 3 sides of digital standards. And sort of growth and interoperability across industries is one of them. That's one of the sides. The other side is competition. So if you, if you're in a place like this, right? If you're in a situation where there's a standard that mediates two industries, that standard is doing actually more work, for better or worse, than just sort of simplifying the connection between these two industries, right? Because it allows industry A, the actors in industry A, to compete to produce data for industry B. And it also, once there's a store of data in a standard format, industry B can actually use that store of data to compete for users. Now that's, for that to actually sort of be in full effect for industry B, like all of the inputs have to be standardized. Like if only a few are standardized and a few others are kind of just swimming around, then competition is still kind of stifled in some way, or at least controlled in some way. But this is essentially like this is a step towards sort of enabling more competition within industry B. But I should point out that this is just basic competition. This is not actually a challenge to IP or a business model. Like the business models are the same, it's just that different people, unless your business model is, unless your business model is essentially, unless having like some, a bespoke kind of vertical column, like within a broader industry, like is your business model, and that is true for some people, including some people in the computer industry, Apple, for example, which has been a very successful company. Like this is just a competition thing. There is actually a set of challenges that are associated with IP privacy in business models, and some of these have started to come up in the context of the standards that we work on, and even in some other contexts. And it's sort of interesting to sort of see the same kind of complaints, the same concerns, coming up over and over again. And to think about, well, rather than all of these efforts independently trying to come up with answers and with approaches to try to deal with these issues, what we should really do as an industry is just recognize that these types of issues exist, and architecturally, like the industry can sort of agree architecturally to to come to a place where we can kind of address them holistically and uniformly. And the solutions are not complicated, actually. So I'll give a few examples where we've had resistance and there have been concerns about privacy and IP. So one has actually been around for a while. It has to do with weather files. So there's TMY weather files that you can get for free, but any non-TMY weather files you have to pay for. But that's kind of a problem, because once for the weather file vendor, you sell a weather file to somebody, that weather file is now out of control, like out of your control. Like, can you actually even sell it to anybody else? Or the person can just put it on put it someplace online. Like that thing is completely out of your hands. That challenge, the fact that once data is out there, you basically lose control of it, has in the computer world, that has the nice moniker, which is making bits not copyable is like making water not wet. It's just not possible. Like there is no solution to this problem. Like you just have to kind of develop like a business architecture that doesn't actually give weather files out to people. It's not that once you give them, like you've already lost the game. Another example, more recent, is ASHRAE Standard 205. So again, trying to connect HVAC OEMs, to BEM, to BEM. Turns out HVAC OEMs are sort of not that hot, about doing exports, detailed exports of their HVAC equipment data, and it's not even that they're trying to monetize it. They just are concerned that having this level of detailed information may actually straight up like leak the IP that is embedded in their equipment. So they don't want that. And then in 229 we have kind of an opposite problem. It's not really an input problem, it's an output problem. So I'm not going to say a ton about 229, but the conceit and the structure relies on having a consistent export from BEM engines that you can then kind of analyze for kind of rule set correctness and rule set consistency. And initially, the sort of the premise was, oh, this will be a very high-level export. It's an export, not an import. It's not something that's kind of designed to allow, kind of input interoperability between BEM engines and people to take their models from one tool to another. But over time, it became clear that the level of detail needed here was maybe a little more than we thought initially would be necessary, and so those concerns rose up. And so vendors are now, maybe reluctant to export because, of this characteristic. Like, do I really want like a full export, of the model to just give it to a user? What if they take that and then give it to to take that to a different tool? Okay. I just want to put this out there. Encryption is great, but it's not. It alone is not a solution. Just giving somebody an encrypted file and say, okay, you can. I'll give you the file encrypted, and then the tool will decrypt it for you. That doesn't solve anything, because to use a decrypted file, the tool has to an encrypted file. The tool has to decrypt it first. You just take the tool, like stop it someplace during, like open up any debugger, stop the program, and just do a memory dump. I stopped Energy Plus and did a memory dump, like in a place where I knew that, the IDF file was going to be. This is it. You just read it out. I mean, it wasn't encrypted, but this just goes to show you that, just stop any program someplace. And everything, once it may not be available as a file, but even if it's available in the internal memory of the program, you can always see it if it's on your machine. So the lesson here is that, if somebody tells you, oh, we can just use encryption to solve it, and then, the software on your machine will decrypt it. Like that's not a complete solution. That's just kind of like that's an arms race type of thing. It makes things it makes the data a little bit more difficult to get your hands on, but not impossible. Okay. Here's the real solution. And it's actually been around for quite a while. And it's a very simple solution. And the computer industry has been using it for, at least a decade, if not more. And that solution is the cloud, or specifically the remote software service. So many companies have moved their software to the cloud. Actually, at this point, many companies in the computer world were never desktop-based to begin with. Like they were on the cloud at birth. And there are a host of reasons for doing this. So the first one is, or an early one was, just eliminating bootleg copies of your program and forcing people to just changing from a business model where you basically sell your software on a CD, or sell the user a copy of the software that they can have on their computer, to something where the software exists on your computer and the user can just use it. And this sort of solves two problems. One is it essentially forces the users to upgrade. Like if you sell the users software and then you want to sell them an upgrade, like next year or 2 years from now, like it's up to them. Like if they're happy with what they have, like they're not going to upgrade. Like you just that income stream is you're not actualizing that income stream. So you basically enter from a one-time fee model to a subscription model. Even more so, you eliminate like bootleg copies, people who basically are using software that they just got from somebody else and not from you. So for a while there was this sort of statistic out there that from Microsoft, only 10% of the Microsoft software copies of Windows in Asia were actually bought from Microsoft. The other 90% were bootlegs. So Microsoft obviously did not want that. But there's more benefits to this. You can gather more data about your users. If your users are doing their work, on your platform as opposed to on their desktop, you can sort of learn more about how they're using your software. You can spend a lot less on kind of troubleshooting like installations and configuration on the user side. There's all sorts of nightmare stories about this. You can leverage elastic storage and compute. So, your user may not have, like a high-end computer that can do like a calibration or a parametric analysis, but you do. So you can kind of give them that service. But then, sort of very relevant to this standardization stuff, is you can protect sensitive data on the cloud. And the reason is, the key is that I can do this because Energy Plus is running on my machine. If Energy Plus is running on the cloud, I cannot do this. I cannot do a cloud. I cannot go to Amazon and say, I want a memory dump of like what's in your server's memory. So, yeah, I see that this is it, right? Like I have to, how much?
20 minutes.
I have 20 minutes? Oh, okay. Why did I think I have until 8? Oh, good. Oh, good, I have time for jokes, too. All right, so guess what happened last night? No. I'll tell you guys later. So the one question is, and if you're starting to think about this and how this may roll out, the one question is who's cloud? Like who is the cloud provider here? And this is a conceptually easy problem. If one vendor is in charge of both the software, meaning the thing that has to actually run the compute, and also all of the sensitive inputs. So if you get your 205 input files, your weather files, and the engine all from one place, then it's obvious that that vendor should be the cloud provider. But what if you are trying to run a simulation that has 205 files from multiple vendors and a weather file from a third vendor, and your BEM tool is a third vendor? So whose cloud are you actually running on at that point? There's an obvious solution here too, but I just kind of want to throw it out. It should be vendor X. It's always is the compute person who should run, who you should be running on. Now, the question is, how is it that, or maybe if not that, then some kind of a third-party provider that's kind of external to all of these actors and acts as kind of an aggregator to all of them. But the question is, if you are a BEM vendor, how, and everything runs on your cloud, how is it that the 205 vendors get their money? So there's a few, even if we're not talking about money, how is it that the 205 vendors kind of know that? Who do they give the 205 the files to ensure that they're not kind of multi-purposed and abused down the line? So there are a few options here. There are actually many options. There are a few kind of building block primitives that you can kind of use to create an architecture that fits exactly kind of the players you are working with and the business that you are trying to create. But a very simple one you can think of is that the vendors of the 205 files simply have some kind of legal agreement with the BEM vendor, whoever that may be. So what happens here is that the 205 vendors essentially do not have agreements with end users anymore. They just provide data to the BEM vendor, and then the users can select that data. And as a result, now the number of, the relationship that you have to control, the 205 vendor, the HVAC OEM only has to control a single relationship, and that's the relationship with the BEM provider. And that relationship can be handled using a combination of technical means, but also just simple legal means. Like if something bad happens to my data and it gets out, I can sue you. Right? That's a very easy thing to enforce. However, what if you do want to kind of go, what if you don't want kind of that kind of arrangement? What if you sort of want to monetize things to users? Well, you can do, here's where you can use encryption. So what you can do in this case is you can sell encrypted 205 files to users, but then don't give them the key to decrypt the files. That you give to the BEM vendor. So the user can own the file and do whatever, but then they can't actually, like they have like a chain of custody to the file, and then they can sort of use it with whoever, but then the key to actually decrypt and run it doesn't belong to them. And all of this works, got it. All of this works, this stuff and all of its variants works because of the mathematical wonder that is known as public key cryptography or asymmetric cryptography, where you use different keys to encrypt and decrypt things. This is one of the most, both beautiful and powerful mathematical results, and powerful meaning impactful, like mathematical results, in math and computer science. And assuming that quantum computing doesn't break it, which it's making progress on it, but I think we can always just increase the number of bits. It basically gives you a way to create any number of architectures that you want to sort of try to, protect, to protect your data, make sure that, it's not abused and it's not sort of monetized downstream without your permission. So here's the 229 example. This one is an even easier one because in this case it doesn't even really require public key cryptography. It requires much simpler symmetric cryptography. So symmetric cryptography is when the key to encrypt and the key to decrypt is actually the same key. Right? It's just the reverse operation. It's the mind-blowing stuff is when there are two different keys. Like, how is it possible that to encrypt and to decrypt use two different keys? Don't think about it too hard. Like, I have a PhD in computer science, and I don't like to think about it too hard. It's just like, it's too much. It's a very mathematical result. So what you do is the BEM engine produces encrypted, RES files, gives it to the user, gives it to the AHJ, and then what do? Well, the BEM vendor also, presumably if the BEM vendor is a cloud vendor, they can also run that file for you. So what have you really achieved here? Like, why even give the file to begin with? If I'm just going to give you a file that then you'll just give right back to me? Like, what is being accomplished here? Well, what's being accomplished is just chain of custody of the file. Like, by giving it to you, you subsequently know, like, that there's some path, that goes from the BEM vendor to me and then back to the BEM vendor, instead of like something internal going on the BEM vendor side. Okay, so that's a feature. Aha. Okay, I'm going to wrap up here with something that's much more abstract. Actually, it's not more abstract. It's much more concrete. Like, this is about the most concrete thing going on in the world today. So what about AI? So AI comes into this in two forms. The first one is, and when I say AI, I mean the new AI. I don't mean reinforcement learning or supervised learning. I mean large language generative AI. So if you've sort of experimented with ChatGPT, or even if you haven't, you've probably heard that that generative AI can basically does a very good job at just translating between things. It's in fact the generative AI technology initially was developed for translating between languages. It only then became kind of apparent. The whole large language model, generative AI thing, was actually in some sense kind of a surprise to the people who built it themselves. Like, they were like, at some point, like, things got to a point of like, whoa, this is crazy. Like, this thing is doing stuff that we never expected. As an engineer, as somebody who believes that, like, if I build something, I should know ahead of time, like, what it's going to do. Like, building something and then having it do things that A, you did not expect it to do, B, even after the fact, you don't understand how it's doing, is a highly disconcerting proposition. But yet here we are. So one question is, if we have this thing that is very good at doing sort of point-to-point translations, does it make like this whole notion of inter-industry standard obsolete? Why don't the different endpoints here just use generative AI to do the translations that you want? So I think there actually is, I don't think this is so cut and dried, and I don't think that this is actually, even if this does work, I don't think that this is actually what we want. I think in the end, we will still want this, even if we do use AI to try to get to it, right? We will still want to define, some human-defined standard, and then maybe sort of reduce the cost of complying with that standard or working with that standard by using AI. But ultimately, we don't want to actually, and I think this is my last thing, is, and this is, this flows right into this next one, and that is, if you think about it, AI itself is not just a mediator between two industries. AI itself is an industry, right? Like it is an entire industry. Like it can be a service provider, a data provider, right? A data aggregator, a service aggregator, for energy modeling. And so what I think is that it's, as we sort of try to understand, and leverage AI, it's important to define a language for BEM that we want AI to speak. We do not want, what AI thinks BEM is to be some opaque thing that's within the neural network, right? We want its sort of internal model of BEM, or it can have an internal model of BEM, but it should be able to express that internal model in some language that we defined, right? I think that's kind of a much more powerful and useful, that's a much more powerful and useful place for us to kind of situate ourselves as an industry vis-a-vis AI. And one reason, for instance, we might want this, I don't know if you guys sort of have heard the term foundation model. So it's like a foundation model is a model that sort of knows that's trained on a large set of something about a particular domain and is essentially an expert in that domain. Now, the model that it has of that domain, it can be a compact model or a language model or some combination of a compact and a language model. But one can very easily imagine that we may want to create a BEM foundation model. We may want to create an AI, an AI model that is an expert in BEM. What language do we want this foundation model to speak to us? That's the question. I mean, there's many other questions, like how do we make one? How would we use it if we had one? So on and so forth. But, for the purposes of this talk, given the fact that this is probably going to happen whether we like it or not, I think we should at the very least try to make it so that whatever this thing ends up being, at least it speaks a language that we can all kind of understand and agree on. This is kind of the summary. Standards are good in certain places at the interfaces with other industries. There are obviously challenges having to do with digital exchanges, but the combination of controlled services and encryption kind of makes a lot of stuff possible and makes a lot of these things kind of go away. And and AI is not the solution for standardization. In fact, it may be even more of a reason for standardization, just so AI can talk to us in a language that we understand. So that is that. And I will take questions, and maybe we can talk about some of these things and in one of the working groups. What's this? The joke. Oh, the joke. Oh, let's see. A priest and a mom and a rabbit walk into a bar. The two ask the rabbit, "What are you doing here?" It's like, "Oh, sorry, fat fingers."
Oh.
Waiting. Okay. All right.
We have a question
Oh, thanks. Yeah. Could you explain that joke, please?
Yes. Does somebody else want to explain the joke? It's supposed to be a rabbi, but it has fat fingers, so you typed rabbit instead. You know?
Got it. I thought it was related to Santa Claus or something, but okay, I get it. So I did want to ask a question about the. Hey, Amir.
Sorry, there's like a light directly behind you. Yeah.
Blinding you. Thinking about standardization, one of the things I've seen over and over again in quote-unquote standardization, and you alluded to it a little bit, is that the point of it is so that industry A and industry B can interact, right? But very often, industry A decides, oh, we need to standardize, so let's make a standard that perfectly aligns with industry A, and it doesn't make any sense to industry B because their input or perspectives wasn't available at the time of the standard. So and a lot of times, it means you have to take, maybe this is just a comment, less than a question, but you have to take into perspective like what the scope of the standard is and what you're trying to communicate across which industries and which knowledge domains. And it takes a lot of effort to understand, you have to have people who understand both sides of what you're trying to communicate to make that happen. But yeah, how do you address that barrier to standardization? Because a lot of standards get created that really are just kind of only serve one industry, right?
Yeah, I mean, I think you have to, as you said, like this has to be, you have to have kind of both industries, present in the stakeholder process. So, in the control standards, for instance, we have modeling folks represented, we have, JCI and, controls vendors represented, and we have, folks from kind of EMIS and controls programming represented. And for BEM, we would have to do the same. I'm not really directly involved in 205. I think OEMs are represented there. Correct me if I'm wrong. In 229, we have some folks who are, the would-be consumers of 229 represented. But you said so correctly, like it can't, if you're trying to work between industries, like that can't really, that product can't be the product of only one of them. I don't have any, it's a people problem. I don't have any, good answers other than, do the necessary people work to address this up front and to make sure that, everybody gets, something useful out of it. Because if, you're right, if the other industry doesn't get something useful out of it, then the whole thing, is just not going to be used, and then it's just a waste of time. Yeah.
Thank you for presentation. I really liked it. I think the question, as you also mentioned it, is basically the ownership, right?
Yeah.
So who owns the data?
Right.
Because that is also a question between us and the clients at times, that they think that they are the owner of our models, and we think that the energy model think that they are the owner of the model and they are just the owner of the report. So that's the question. And also the privacy, because now you are uploading operation hours, the energy cost of that specific building to the cloud.
Yeah.
And so in order to understand your point, I'm going to dumb it down a little bit. Maybe you can fix.
Or probably not. Yeah.
You
go
can
ahead.
you can fix me if I'm wrong. So what you are asking here, imagine that we are all here, either energy modelers or architects. So we are working here together, and you are the cloud vendors here. You're like, or the guy who is doing the standardization. You are not part of this group, and you're coming here and saying, oh, guys, I think that you have to share all the data to me because I make your relationship here easier. And you do, by the way. But the question is, now you are having access to aggregated all the data, right? So you are the bank of the information, and you can use AI. So you will be the owner, basically. That's what I want to say, eventually. Don't you think so?
Yeah. I mean, do you have a Gmail account?
Yeah, I agree. That's the
Do
future.
you have Facebook? Do you have any of these things?
Yeah.
I mean, your data is theirs. Of course, all those things are free, right? If you're using a paid service, I mean, I think that's something to kind of be negotiated. And of course, there's, there are solutions to, like, there's a ton of variants for all of this stuff. Like, for instance, here, you can have a situation where the BEM vendor, like, that runs the stuff, like, that key is, like, specific to you. Like, you purchase the key, and that key is like a timed key that's given to, like, the BEM vendor, and you can kind of run it, but and then renew it. Like, there's all sorts of ways to, like, make sure that, like, whatever just because the BEM vendor runs stuff, like, doesn't mean that they own it, like, clear text versions of it in perpetuity. Of course, there's always this problem, like, even if they own it, like, sort of for a little while, they can always just kind of, like, freeze it, like, in memory, like, and download it and, like, sort of see what's going on with it. But again, I mean, I think this is, you have to, kind of divorce the, and this will be the last question, and we can talk about this afterwards in the working groups. You have to divorce kind of the business model. You first have to decide, like, what is the business model that you want? And then you use, the cloud and encryption primitives to implement that business model. Like, if there's, like, no clarity up front, like, if you just sort of implement something, but there is no agreement or clarity up front, and you try to post-fact, like, bolt on, oh, wait a second, you already have all this stuff, but I actually own it, by then it's, like, it's too late, like, or, the horse is out of the barn. Like, you really have to, think ahead of time, like, when designing a system, like, what characteristics of ownership you want that system to have.
Thank you.
Yeah. All right. Thanks, everyone. We're at time.
Thanks, Amir. And sure enough,